Hi, I'm Audrey, member of the Teen Advisory Board with the Howard County Library System. Today I'm going to teach you guys about vertex form. Now, you're probably used to seeing quadratic equations in a form that looks like y equals ax squared plus bx plus c. Vertex form is another way to express the same equation, but instead of looking like this, it looks like y equals a times the quantity of x minus h squared plus k. And I know you're probably thinking, where did all these new letters come from? What's this about? How do you get from this equation to this equation? And why would you want to? I mean, I'm hoping you're thinking all of those things. So the vertex form is used to find the vertex of a parabola. A parabola looks like this graph here. So you're either either concave down, like this parabola, where both ends of it are pointing in the negative y direction. And in that case, you've got a maximum right here. You can see that's like the top point of the graph, where it has a corner. You could also have a parabola going in the opposite direction, like that, and its vertex would just be there. So that's a vertex, a corner. And when you're thinking about the vertex form of a quadratic equation, the h and the k correspond to the coordinates of the vertex of that equation. So, for example, for said equation, over here, hk are the coordinates of its vertex. So we're going to do an example, and we're going to start with an equation in vertex form. Y equals x plus 2 squared plus 3. And we know how to FOIL, so we're going to take this equation from vertex form to quadratic form by FOILing out the x plus 2 squared. We're going to see what that looks like and see if we can try to use it to go from quadratic form to vertex form. So let's start by rewriting this as x plus 2 times x plus 2, because that's what x plus 2 squared is, plus 3. And then we can use FOIL to get y equals x squared plus 2x plus 2x plus 4 plus 3, because that's that plus 3 there. And then combine like terms to get x squared plus 4x plus 7. So this here is the form that we're used to, and it's not that many steps to get from here to here. The only really tricky part is you have to do something called completing the square. Because in vertex form, you have this quantity here squared. So you need to find a way to take this expression and factor it in a way that gives you a quantity squared. So we're going to continue with this equation here, and we're going to try and retrace our steps to find out what the vertex form is. And we should be able to check and make sure that it is x plus 2 squared plus 3. So let's try that. Starting with y equals x squared plus 4x plus 7. Now, to start completing the square, you can think of just ignoring the constant at the end of your quadratic equation. Remember, quadratic equations, the form that we're dealing with here, is ax squared plus bx plus c, where c is a constant. So that constant there, 7, we're just not going to think about it for now. Just looking at these two terms, x squared plus 4x, there is some number that we can add to these two, some constant, that will give us a quantity squared. And you find that number with the equation, let's call 4 b, because 4 is b over here. B over 2 squared is going to give us our question mark. So in this case, we've got 4 over 2 squared, which equals 2 squared, which equals 4. So if we want to go back here and we want to complete the square, we can say x squared plus 4x plus 4. And let's make sure to carry down that 7 as well, plus 7. But you can't just add 4 to the equation and have it still equal y. So since we added 4, we're just going to go ahead and subtract 4, because 4 minus 4 equals 0. So if we add 4 and subtract 4, we're not actually changing the equation at all. But now we've got this set of numbers here, x squared plus 4x plus 4. And we did this whole b over 2 squared thing so that we could find a number that would be able to be factored into a quantity squared. So now let's look at this and let's factor it. When we're thinking about the factors of 4, you've got 1 and 4 and 2 and 2. The only ones that add to 4 are 2 and 2. So factoring that, you're going to get x plus 2 times x plus 2. Then we're keeping our plus 7 minus 4. And of course you can see that that is x plus 2 squared. So you've got x plus 2 squared plus 7 minus 4. And we can simplify that to x plus 2 squared plus 3. And if we go back and check, that is the equation that we got before. Alright, now that you've got the idea, we're going to go ahead and do an example. We're going to do y equals x squared plus 8x plus 9. And we're going to complete the square and find the vertex form. So remember, let's just start out by ignoring this 9. It exists, but we're not going to think about it for a little bit. We're just going to look at the x squared plus 8x. Specifically, this b value right here. We remember our equation, b over 2 squared equals our magic number. So we're going to take 8, do 8 over 2 squared, which is going to equal 4 squared, which is going to equal 16. So 16 is the number we need to have in this equation in order to be able to complete the square. So we're going to say x squared plus 8x. Whoa, that's not an 8x. Plus 8x plus 16. We can't forget the plus 9. And then, because you're adding 16, and you can't just do that, we are also going to subtract 16. Now we've got an equation that is exactly equal to the equation we had up there. And we have our completed square. So then, if we factor just this section of numbers here, we're going to get x plus 4 times x plus 4. Whoa! Plus 9 minus 16. Simplify that to x plus 4 squared minus 9 minus 16. Ooh, arithmetic. 7? That is 7, right? Yes. And that's going to be our answer. So remember, we're using vertex form to find the vertex of the parabola. And when we're going back and looking at the graph, the vertex is at hk. But if we look at our equation for vertex form, it's x minus h plus k. So if we had this equation here, and we wanted to know the vertex of the parabola, the answer would not be 4, negative 7. That would not be the answer. No. Because 4 is not the h value. If you were looking x minus h squared plus k. 4 is not h. In order to get x plus 4, you would need to substitute in a negative 4. So you can see h does not, oh my goodness, h does not equal 4. H equals negative 4. And that's going to be true every time you have x plus something, it's going to be negative something. Every time you have x minus something, it's going to be positive something. So in the case of this equation, your vertex is going to be negative 4, negative 7. Thanks. I hope that helped.